All right, I'm actually not going to do the derivation of these formulas. We've done that enough in class. I'm going to actually have you practice it until you're fluent. So for number 2, I'm going to start actually with number 2. And I'm going to use this version of the range formula to show that its complement also gives you the range. One thing, never do this again on an exam of mine. Do not plug in 30 and 60 degrees. I will take off huge numbers of points in the future. When I say an angle and its complement, I mean any angle and its complement. So you test in the following way. The definition of complement is 90 minus the angle. So what that means is you need to put 90 minus theta here and 90 minus theta here. Note, cosine of 90 minus theta equals sine of theta. And sine of 90 minus theta equals cosine of theta. So what does this tell us? This means that the range gets modified with the complement to, we start with this formula, and then this ends up being 2v0 squared, and we swap it out. This is simply sine of theta, and this is simply cosine of theta. So it's the same. That's what we mean by a proof. You know this from geometry. You need to adapt it to physics. Okay, so never, ever again plug it in with a real angle. Ever. Okay? You use variables. You prove it for every case, not just for one. Okay? Now, next thing, let's go ahead and talk about hang time for the complement. So, starting with the hang time formula. So there's the hang time for the angle. The hang time for its complement will be cosine of theta. Given this little thing that we had here, that 90 minus theta is the cosine. And so the difference in the hang time is going to be 2v0, it's going to be the following: 2v0 cosine or sine theta minus cosine of theta divided by g. Divided by g. So that is, in fact, our answer.